Okay, here we go. That's where we were, right? Okay. So let me know when you're done. Is everybody done? Or? Okay, so let's look at this. Now, first of all, we want to find the p hat. That's just basically your x over your n. The number of successes over the sample size. Now, remember, it should be a decimal, okay? A lot of times, what people will do by mistake is they'll put the n divided by the x. They'll flip these two. If that happens, you'll really quickly find out it's going to be wrong, okay? So make sure it's x divided by n, okay? And then your q hat is basically 1 minus the p hat. But what they're going to ask you is to find the point estimate. In my stat lab, they're going to say, what is the point estimate? That's going to be that x divided by n, okay? Okay, so our next step is going to be to check and see if it's a normal distribution. Now, what we do is we take 0.969 times 224, your p hat times your n, okay? And then we're going to go ahead and take the q hat times the n and make sure that it's greater than or equal to 0.5. Okay, so that's actually much, much greater than 0.5, than 5. And this one right here is also going to be bigger than 0.5. So why do I do that? Just to know that you have a z-test. Okay, just to know that you can use the normal distribution. Don't even have to worry about t anymore. Just z. Okay? So on this one, on the proportions, you're going to go back to z. Now the next thing that you're going to do is this. Okay, so we have our hypothesis. Test the claim that the proportion is greater than 0.95. Okay, that's your answer. Now, your critical value, same way that you did it before, 0.01. Okay, and it's greater than, so it's on this side. You give it the same way that you do before. Okay, you take you say this 0.01, and you're going to go over here. Just going to show you how to find the critical value again, because you're going to have to do this in a test. Now notice that this time, this critical value is on the right side. So in order to find that value, you're going to have to take 1 minus 0.01, that's at 0.99, take second inverse norm of 0.99, and that gives you 2.33, or 2.323. Okay, or I'm sorry, 2.326, that's what it is. See, it's the same thing. So you get that critical value, then you're going to find the test statistic. The formula for the test statistic is this one, the p hat minus the p, and what this is basically the sample proportion minus the population proportion divided by the standard error of proportions. Okay, this is what the standard error for proportions. But this is the formula you would use. You would put them in there, calculate it, and you get 1.305. So where is that 1.305? It's going to be? That's right. Is it going to be in the rejection region? No, it's not going to be in the rejection region. So we do not reject the null hypothesis. Okay?
How come you're using Z instead of P like the other times?
Z. Okay, well, no, we can do it with P's also.
Okay.
Okay? What I did was I did it through critical values, and then I'm going to do it with calculator.
Okay.
But this is doing it without the calculator. Okay, so now because we do not reject, I do not have enough evidence. Say in terms of the alternative. I do not have enough evidence to say that it's greater than 0.95. Now, let's look at it again, but now we're going to do it like you said, with the p-values. Because you can. You can just do it with the p-values. This is the biggest thing you have to remember if you're going to do it with the p-values. Why do I tell you about critical values? Again, because there's going to be several places where they refer back to critical values. So I want to make sure that you're informed, that you know when they start talking about critical values is, what in the world are they talking about? That's what they're talking about, okay? Now, if you do it by calculator, what you're looking for is your p-value. If your p-value is less than your alpha, you reject the null hypothesis. If your p-value is greater than your alpha, you fail to reject the null hypothesis. Okay? So now, let's look at this. We have this right here, same stuff. We're just checking to see if it's greater than 5. We already know this. We already know that it's a normal distribution. Now, test the claim that the proportion is greater. We already done this. It's all the same stuff. What I'm saying is now we're going to do it with a calculator. Okay? Let's look at the level of significance. Okay, so I'm going to go over here. I'm going to go to my calculator. Okay, so now where I'm going to go here is going to be, I'm going to go to stat. I'm going to go to test. And now I'm going to go to a 1 prop Z test. 1 prop Z test. So we're going to go over here. Okay, this is our P sub O. This is this right here. Okay, so that's going to be 0.95. This right here is the number of successes. That's 217. And this is your N, 224. And now this right here is from this alternative right here. See that? That goes for this. So we're going to move this until you have greater than. And then you hit the calculate button. And you get your p-value and your test statistic. See that? Your p-value is 0.0989. Your test statistic is 1.287. Okay, so the p-value is 0.09, which is greater than 0.01. So you fail to reject the null hypothesis. Do not have enough evidence to say that the proportion of brides want roses is greater than 95%. So any questions on that? Now the other way to do this is through StatCrunch. Okay? So with StatCrunch, you go over to StatCrunch right here. You would go to Stat. You would go to Z-test. Well, I'm sorry, not Z-test. You would go to proportion stats, 1 sample with summary. The number of successes was 217. Okay? So your number of successes was 217. Your sample size was 224. Okay, you're wanting to do a hypothesis test, and your hypothesis was 0.95, and your alternative was greater than. So that's going to be greater than. Okay? So you have everything. You're going to compute, and you're going to get your answer. You're going to get your p-value. Your p-value is 0.0989. Your test statistic is 1.287. It's a little bit off. Why? Because of the rounding issue. Okay? So if you have it here, well, it's not that off. No, it's not off at all. See, it's the same thing. Okay, so any questions on that? Okay, so now I would like you to try this one on your own. See what you get.